So today we'll start with the standard form and the root form. It's very important that you know these forms. Now, if you remember from the early on this school year, I asked you all about the linear equations, the slope-intercept form, point-slope form, and standard form. Now, if you know them all, great, because we extract information through those forms. Like if you know the slope-intercept form, y is going to mx plus b. If you see a linear equation that happens to be in that form, then you can tell the slope, you can tell the y-intercept. And that's the same reason why we need to know the different forms of quadratic equation. So first, what is the standard form? It is a squared plus bx plus c. And if you know the standard form, what easy information you can spot out from the form itself? We can say, hey, if you know the c value, that is the y-intercept. And if you know whether the a value is positive or negative, then you can tell, kind of like the slope, but they also tell the opening upward or opening down. Is it upside down? Is it right side up u? Parabola, or the right side upside down u. So these are the easy things you can tell, okay, by just taking a quick glance at it. Now, if you know the standard form, do you know the root form? Okay, do you know the root form of quadratic equation? Again, it's about your recognition. If you don't know them, then this is now a very urgent time that you must master these things, okay, from now on. This is the root form. So if you can factor it, having the quadratic equation to be expressed in this way, then you know the root or the roots. And the roots are related to what? On the graph. The x-intercepts, okay? Now you could use the roots to further the investigation of the vertex, because the vertex must be right in between the two roots, okay? So we have these two root forms. Now I'm going to hold off to the vertex form until tomorrow, but I mean it doesn't hurt to write it here. The vertex form, it's going to be vertex form is going to be y is equal to a times x minus h parentheses square plus k. If you watched my videos while I was gone, you remember that a lot of people, they might miss out the square, okay, because they focus on the h and the k and the a, but they might forget the square. But it's very important that you know there must be a square either explicitly or implicitly, okay? Like for the root form, it is square because x is going to be multiplied by x. So that's how you get your square. All right. Vertex form will be useful for tomorrow. Okay. Now, since I haven't seen you for about a month, I'm going to ask you for a simple word. Do you still remember what the word soft means? The value of values that makes a statement true. Okay, like I said, a lot of people don't know this word, and that's why they keep on struggling in math. But if you know it, then it's fine. So what we're trying to do here is that find value or values of x so that this would be true, so that the inequality is true. So how do we do it? Well, there are two ways we can do it. But before we look at the two different ways, let me ask you a quick question. If you just stare at this quadratic expression right here, x squared minus x minus 2, can you think about the factors? Okay, can you factor it? Okay, like now I'm asking you to factor it, but one key component or one key skill that you must master here in this course is that, are you able to factor it without being prompted? Are you able to entertain the idea that maybe, can it be factored? And if it's yes, what would be the factors? It'll be x minus 2, x plus 1. Okay, because minus 2 times positive 1 gives you negative 2. And then when you do the inside and outside, the outside would be x. The inside would be negative 2x. And when you add them together, combine like terms, that's how you get your minus x. So that's how you double check yourself and validate your factors. Now, so this is where we'll start. So let me go ahead and write down the inequality again. So now we are going to find out something called a critical value. Okay, it's very critical because it sets up the borders. And so let's go ahead and factor this, which we just did. So I'm going to write it here. Now, to find out the critical value or critical values in this case, we will temporarily change the inequality sign to equal. Again, we are trying to set up the borders. Okay, we are trying to find out where it is at 0. And from that point, we can have a better perspective of, oh yeah, then I can tell where it's greater than 0. But first, let's investigate where it is at 0. So, so we write the same thing here. So this is just like what you did before, right? You have the equation, you factor it, you set it equal to 0. And because you have this times this equal to 0, and that's why you have 2 possibilities. And if you watched my video on the test review, I said it very genuinely and seriously that everybody should know how this becomes this. Okay, everybody should know how this line right here becomes this line right here. Do not just follow procedures. So many students, they just follow procedures and they are missing out the key concept right here. Okay, so again, we go from here to here because if you have 2 things multiplying together to get you 0, that means you have 2 possibilities. This could equal to 0, or this could equal to 0. And then based on these 2 possibilities, we investigate what x would be. And we say, oh yeah, x is equal to 2 and x is equal to negative 1. That's how you have the whole thing equal to 0. Are we okay so far? Are we good? Yes? Next, we have to test the interval because now we only find out the points that it's equal to 0, but we want to find out where it's above 0. So we say, all right, no problem. Let's go ahead and set up our number line, and we put our roots or our critical values onto the number line. And what we will do now, we will go ahead and test the intervals. Okay, if the interval, well, we will look at the values that we get produced from these intervals, and then we will take a look at the intervals and see whether they are solutions or not. So again, our job is to find out the x values. And that would give us the quadratic equation to be a quadratic expression to be greater than or equal to 0. So let's go ahead and test a value that is less than negative 1. Okay, so for simplicity, I would just go ahead and pick negative 2. Okay, I mean, you can pick any number, but you know, keep it convenient. So if it's negative 2, now you can put it back to either this expression or this expression. And I would choose this one because it looks easier. So if you think about negative 2 going to the x in these 2 places, so negative 2 minus 2 would be negative 4. Negative 2 plus 1 would be negative 1. So so you would end up with negative 4 times negative 1, which is positive 4. So in this case, we will put a positive sign above the interval here. So while we're at this interval, should we include this interval into our solution? Again, solution solving means to find the values, to make the statement true, and the statement is what? This thing must be greater than or equal to 0. So should we include this interval to our solution? You say, yeah, we should. Anything from negative infinity all the way to -1 should be our solution, because they will create values that's greater than 0, because it's going to be positive. Okay, and at -1 it will be 0, so it would also be our solution. Now, then you think about the interval between -1 and 2. We say, let's pick a number. We pick 0, easy enough. So if you put 0 into these two parentheses, you would get -2 times 1, which is -2. So therefore, you would have a negative number, and that means it's less than 0. So that is not our solution. And then we keep going, and we say, all right, let's go ahead and test the interval to the right-hand side of 2. So pick a number that's greater than 2, and we'll go ahead and pick 3. And then we say, yeah, what about 3 going to the x's right here? And we say, well, 3 minus 2, it's 1. 3 plus 1 is 4, which gives you 4. Okay. And in that case, everything here should give you a positive value. And we say, hey, that's positive also. So this interval would also be our solution. Okay. This interval would also be our solution. So the way we will conclude our problem here is that what is our solution? Our solution goes from -infinity to -1, bracket. And then we have another interval, so we use union as a way to include our next interval. All right, so we say union, okay, so includes the other segment right here. So that's our solution, okay? So again, it's like what you have done. We factor, we solve, but we are only solving for the values that would give us 0. And then we've got to test the intervals to see if the intervals are going to give us the proper values and to make the statement true. And we only include the x values that would make the statement true.